Today, we will be talking about solutions. So, you know from experience that sugar dissolves in water. Sugar is described as soluble in water. By soluble, we mean capable of being dissolved. When sugar dissolves, all its molecules become uniformly distributed among water molecules. The solid sugar is no longer visible. Such a mixture is called a solution. A solution is a homogeneous mixture of two or more substances in a single phase. This is going way back to September here. So homogeneous mixture, single phase, right? Heterogeneous mixture, two or more phases, usually two. Okay, so the dissolving medium in a solution is called a solvent, and the substance being dissolved in a solution is called the solute. So, our solvent, our universal solvent, is water. So solutions may exist as gases, liquids, or solids. There are many possible solute-solvent combinations between gases, liquids, and solids. So example, alloys are solid solutions in which the atoms of two or more metals are uniformly mixed. Brass is made from zinc and copper. Sterling silver is made from silver and copper. So this slide just shows us a couple, or two types of solutions. One, liquid solute in liquid solution. So we have ethanol mixed with water. In this one, we have a solid solute in a solid solution. We have a mixture of silver and gold. So now, electrolytes versus non-electrolytes. So a substance that dissolves in water to give a solution that conducts electric current is called an electrolyte. So any soluble ionic compound, such as sodium chloride, NaCl, is an electrolyte. The positive and negative ions separate from each other in solution and are free to move, making it possible for an electric current to pass through the solution. A substance that dissolves in water to give a solution that does not conduct electric current is a non-electrolyte. So sugar is an example of non-electrolyte. Neutral solute molecules do not contain mobile charged particles, so a solution of a non-electrolyte cannot conduct electric current. I'm going to go back to electrolytes for a second. I'm sure everybody's had a sports drink, Gatorade, Powerade, Body Armor. They talk about electrolytes in there. Potassium, sodium, magnesium, things of that nature. So now, electrical conductivity of solutions. So, if we have an electrolyte present, okay, we're going to see this light bulb go on here. And in this first solution, sucrose, we do not see the light bulb on at all because we know sucrose is not an ionic compound, so it's a non-electrolyte. Acetic acid, okay, the light bulb's on a little bit. It's a weak electrolyte. Sodium chloride's getting stronger. It's a stronger electrolyte, and the strongest of the three is hydrochloric acid. So now if we look here, is this an electrolyte or a non-electrolyte? So NaCl, sodium chloride, it's ionic compound, so it's an electrolyte. HCl, we just saw, had the strongest conductivity on the slide before, so that's an electrolyte. KOH, potassium hydroxide, ionic compound, is an electrolyte. Now, sucrose is a non-electrolyte because it is not an ionic compound. It is a molecular compound. Okay, so now we're going to talk about the solution process. So, solution formation. The compositions of the solvent and the solute determine whether or not a substance will dissolve. So factors that affect how fast a substance dissolves include agitation, temperature, and particle size of the solute. So if the contents of the glass are stirred, the crystals dissolve more quickly. The dissolving process occurs at the surface of the sugar crystals. Stirring speeds up the process because fresh solvent, the water, is continually brought into contact with the surface of the solute, which is the sugar. So, agitation, stirring or shaking, affects only the rate at which a solid solute dissolves. It does not influence the amount of solute that will dissolve. An insoluble substance remains undissolved regardless of how vigorously or for how long the solvent-solute system is agitated. Next one is temperature. Sugar dissolves much more rapidly in hot tea than iced tea, because at higher temperatures, the kinetic energy of water molecules is greater than at lower temperatures, so the molecules move faster. The more rapid motion of the solvent molecules leads to an increase in the frequency of the force of the collisions between water molecules and the surfaces of the sugar crystals. So, particle size of the solute. The rate at which a solute dissolves also depends upon the size of the solute. The smaller particles in granulated sugar expose a much greater surface area to the colliding water molecules. The dissolving process is a surface phenomenon. The more surface area of the solute that is exposed, the faster the rate of dissolving. So, which of these will not speed up the rate at which a solid solute dissolves? So, a lot of multiple choice questions are process of elimination. So we had a whole 2 or 3 slides on increasing temperature speeds up the rate at which a solute will dissolve, so it's not that. Agitation is stirring, so we talked about that. Crushing, the amount, we talked about that. Decreasing temperature will not speed up the rate at which a solid solute dissolves. And this concludes our first video on solutions.